A system worth hundreds of millions of dollars is doing something that sounds impossible, lifting ships that weigh thousands of tons more than 100 meters into the air, not with magic, but with math, gravity, and the power of infrastructure. In reality, there are ships quite literally driving through the sky, moving along water channels suspended between mountains. It sounds like science fiction, but this is already reshaping transportation costs, product prices, and the economic advantage of an entire nation. And here is the part most people miss. This is not just an engineering project. This is how a system gets redesigned so that money starts flowing in a completely different direction. There are ships that weigh over 3,000 tons. That is roughly the weight of 500 elephants, and they are not moving through a river the way you would expect. They are being lifted straight up, like an elevator, rising more than 100 meters in the air in a single controlled motion. And the entire process takes about 40 minutes, not hours, not half a day, just 40 minutes. Now compare that to the old system where ships had to pass through multiple lock stages, each step raising the water level slowly, turning a single crossing into a 3 to 4 hour delay. And when you scale that across hundreds of ships, across entire supply chains, the lost time becomes lost money. But here is where it gets even more interesting. These ships are not just crossing a dam anymore. They are crossing geography itself. Mountains, elevation, natural barriers that once defined where trade could or could not exist are no longer limits. They are being engineered out of the equation. And that changes something fundamental. Because the moment you remove geography as a constraint, you are no longer just improving transportation. You are rewriting the rules of where economic activity can happen and who gets to benefit from it. Rivers are the cheapest transportation system on the planet. A single cargo vessel can carry the same load as hundreds of trucks, using less fuel, fewer workers, and far lower cost per ton. In many cases, transport by river is 3 to 5 times cheaper than road. And that cost advantage scales fast when you move bulk goods like steel, grain, or energy. In the United States, the Mississippi River system acts as a central artery for the economy, moving massive volumes of goods between the interior and global markets. In China, the Yangtze River plays a similar role, connecting industrial cities deep inland to coastal export hubs. Every year, hundreds of billions of dollars worth of goods flow through these waterways, and entire industries depend on that steady movement. But this system has a critical weakness. It only works if the river flows without interruption. Ships rely on a continuous path. A single broken link can disrupt everything. And when that flow is blocked by something like a dam, the river stops being a highway and turns into a dead end. And once that happens, the cost advantage disappears, the delays begin, and the entire economic chain behind it starts to slow down. Dams solve one problem but quietly create another. They generate massive amounts of electricity, control floods, and stabilize water supply. But at the same time, they introduce a new barrier that most people never think about: elevation difference. And this gap can reach over 100 meters, the height of a 30-story building, which effectively splits a single river into 2 separate worlds. Upstream and downstream no longer connect in a continuous path. And for cargo vessels that depend on that continuity, the journey simply stops. Ships cannot climb. They cannot bypass the structure. And without a solution, the entire logistics chain breaks at that point. Historically, the answer was locks. A system of water chambers that raise or lower ships step by step. It works, but only up to a certain scale. Because the higher the dam, the more steps you need. And each step takes time. Ships must enter, wait, adjust water levels, then move again, over and over. And as the number of steps increases, so does the delay. What used to be a smooth flow becomes a slow, mechanical process. And that delay has a cost, because every extra hour means higher fuel use, higher labor cost, and fewer trips completed. And when time expands, logistics costs do not just rise, they compound across the entire supply chain. A multi-stage lock system can take 3 to 4 hours for a single ship to pass, each chamber adding delay, each step adding cost. But a ship lift can complete the same elevation change in just 40 minutes, cutting nearly 80% of the time. And that difference is not just operational, it is economic. At the Three Gorges Dam, ships weighing up to 3,000 tons are lifted 113 meters in a single motion. And this system alone has reduced shipping costs by around 25%. Now think about what that means at scale. If a major route handles 1,000 trips per year, that time savings translates into millions of dollars saved annually. Fewer delays mean more trips completed. More trips mean higher capacity without building new routes. And lower cost per shipment means goods can be priced more competitively. Industries along the river gain an advantage. Manufacturers can move raw materials faster. Exporters can reach global markets more efficiently. And over time, those savings compound across entire regions. But here is the key point. This is not just about saving time on one route. This is about reshaping the economics of an entire transportation network. Because when you compress time and reduce cost at this scale, you do not just improve the system, you change how the system behaves. And that is where the real shift begins. Locks are old technology. They work, but they were designed for a different scale, a different era of trade. Ship lifts are the leap forward, faster, more efficient, and able to handle massive elevation in a single move. But China did not stop at improving one component. They redesigned the entire system around it. Instead of a single lift, they built a sequence of 3 connected lifts, each handling different height ranges, linked together by elevated canals, stretching over 2.3 kilometers, suspended more than 100 meters above the ground. This is where the shift becomes undeniable. Ships are no longer constrained by the natural shape of the land. Mountains are no longer barriers. Rivers are no longer broken into isolated segments. The flow becomes continuous again. But now it is engineered, controlled, optimized, and that changes everything. Because once geography stops being a limitation, logistics becomes a design choice. Routes can be planned based on efficiency, not terrain. Regions that were once disconnected can now plug into major trade networks. And this is no longer just infrastructure in the traditional sense. This is the reconstruction of an entire logistics map, where movement is no longer dictated by nature, but by systems built to override it. But this is no longer a story about ships. The real shift is not about lifting vessels, it is about lifting the entire economy behind them. Because the moment you reduce transportation cost, you change where factories choose to operate. Industries move toward efficiency, and capital follows lower friction. When remote inland regions suddenly become accessible, they are no longer isolated. They turn into new markets, new production zones, new centers of growth. And that changes the balance between regions, because access is power. And logistics defines access. When you control a river system, you are not just managing water, you are directing the movement of goods, energy, and raw materials. And that means you are directing money. Because every shipment carries value, every route carries opportunity, and every delay or advantage compounds over time. Ship lifts do not just help vessels cross a dam, they determine which cities become industrial hubs, which regions attract investment, and which areas fall behind. And once those patterns are set, they are very hard to reverse, because infrastructure shapes behavior, and behavior shapes the economy. So what looks like a mechanical solution is actually a strategic lever, quietly deciding winners and losers across an entire nation. The United States is already planning a new ship lift in Alabama. Australia is investing over $200 million into a major facility in Darwin, and this signals something bigger. The race has already begun, not to build more ships, but to build the systems those ships depend on. Because the country that optimizes its internal logistics will lower costs, scale production, and attract capital faster than everyone else. And over time, that advantage compounds into control over supply chains. Because in the end, it is not the ship that defines the future. It is the path it can take. Because when you control the flow, you control the money. Subscribe to see where that flow is moving next.